Okay, 6.5, last one. Now we're back to straight up probability instead of all the other stuff. So, you had 4 vocabulary words. Independent. Those events do not interact. Flipping coins are independent. Rolling dice are independent. Pretty much whatever you do the first time has no effect on the second time. Whether or not the power is out in California and whether or not the power is out here is completely independent because we don't have any linked system. There's nothing that affects it. Now, whether or not there's a storm here and whether or not our power is out might be dependent. One causes the other, or one is a product of the other, or one stops the other. We are playing the independent-dependent game with the social distancing. Depending on how good we can be at social distancing, is going to determine how bad the virus is or how quick it's going to spread. This is how statistics affects your y'all's life. This is why this class is required. But the problem with explaining that sort of thing is you need so much background to really understand what everybody's doing that it's hard to explain what's going on without it just sounding like junk. Because, I mean, we're playing an independent-dependent game. If the virus is dependent on us talking to each other, if we don't talk, maybe we can stop it. Or slow it down. So independent things do not interact. Dependent things deal with each other, and they don't necessarily have to be completely dependent, but they do have to affect one another. Mutually exclusive means they cannot happen together. My favorite one is in the college classes is married, widowed, and single. You can't be married and single at the same time. You're either legally married or you're not. Those are your choices. However, you can be married and widowed. If you're on your second or third marriage and your first one ended with the death of a spouse, that means you are a widow, but you've remarried. So you're married and a widow. Those two things, while they're not exactly the same thing, you can have them together. So mutually exclusive means you cannot have them together. I cannot be in California and in Virginia at the same time. I can have a residence in both places, but I physically cannot be in both places at the same time. That's exclusive. But things that can happen at the same time, you can be a student at a high school and a student at a college at the same time, even those two things are very different. But you can be a student in both places. Those are called overlapping in this book. In fact, they kind of ditch mutually exclusive for overlapping and non-overlapping. However, this whole section you can pretty much do without knowing all this. You can do this by being a fairly careful and good reader. You can use the English language to work these problems out without having to know the math. Now, if English is your second language, this makes it worse and not better. But if English is your first language, I'll show you how to do that. Okay, the first one. If you carefully read problem 15, it will tell you what are the chances of picking someone who pled guilty or went to prison. Now, in math, and it's on the next page, in math we have what is called an inclusive or. You can plead guilty, you could have gone to prison, or you could have done both. Exclusive or would mean it's either one or the other, but not both. Math does inclusive ors. You can have one, you can have the second thing, or you can have both things together. So, if you're looking at the little chart on page 15, actually it's on page 224 for number 15, you will notice, and I'm looking at the individual little blocks there, not totals, that I've got 392 people had a guilty plea and were sent to prison. So that would be my both. I have 564 people who were guilty, who pled guilty and then didn't go to prison. Got my notes wrong there. And then I also had 58 people who went to prison even though they didn't plead guilty. But that gives me all the people that pled guilty, all the people that went to prison, and the group of people that did both. You will notice pretty much it's everybody except the people that didn't plead guilty and didn't go to prison, those 14. So I also could have done the total, which is 1,028, and subtracted out those 14, and that would be my top number. Or I could add those individual 3 groups together. But you still get the same thing, 1,014 over 1,028. And again, I don't want you guys to reduce these fractions. I prefer to see 1,014 over 1,028 because that means you looked at it and you knew what you were doing. Alright, so let's turn over and look at 16. There's another way to think about this too. And this is part of the married and single and widow thing that I do in class, which I can't do now. If you take each one of those columns adds up to a total, each one of those rows adds up to a total. So the first column, the 392 plus the 564, 956, 956 people pled guilty. That's not counting whether they went to prison or not. And then we had 72 that pled not guilty. And then we had 450 that went to prison. Then we had 578 who did not go to prison. The problem is when you count those this way, you have to be real careful because you're going to count some people 2 times if you're not careful. So if I want all the people, this one is not guilty or not prison. So 72 people pled not guilty. That's cool. 578 people did not go to prison. Also good. But you need to notice that you counted the 14 people that pled not guilty and didn't go to prison 2 times. They were in the row addition, they were in the column addition. So I've got 72 plus 578, and then take away the 14 people because you counted them twice and you only want them once. That gives me 636 over 1028. Now if you're checking stuff in the back of the book, they go to decimals at this point. All mine are going to stay fractions. I just prefer to see those fractions because I know what you did as opposed to all those just random decimals. Alright, so 17 is independent versus dependent. As far as you know, none of those defendants are related to each other. None of them were flipping on one another. So picking one and then picking another, that's just the way it is. Guilty over total. 956 over 1028 2 times multiplied together gives you that humongous fraction. Leave it like it is. The rest of them I just detailed out. I tried to put in the words for these because that usually makes it easier. If you prefer the formula, your textbook does this formula style. So you have 2 choices. You can listen to this, tiptoe through the notes, and do it with words, talking to yourself. Or if you prefer the formulas, read your textbook. That's the reason you have both. That way you have choices. You've got me for one thing, textbook for another. I did all 26 problems. I left them all as fractions. I'm going to get off here now and write the test exactly the way I told you guys from before. About 70% of the test will be just taking these homework problems that I've done that you have copies of, putting them on the test, and then about 30% will be similar problems. All you're doing is changing the numbers. So, and I'll see you guys Thursday. I don't even know what class is what now. I think I'll see you guys Thursday from 5 to 8. Be sure to check in.